So I wanted to show you how to do some of these. That way, if you want to, you could just watch this video and start doing the last assignment for this chapter already. And really, the way they make this work is that they try to get like common denominators and then, see if you can make it all work out pretty well. Now, I have some other ways to approach this. Like number 9, number 11, I look at the fact that there's something on the bottom on each side, and I'm like, I just want to get rid of it. And the way to get rid of the n, for example, is to multiply both sides times n, because then this side cancels out. Same thing. If I want to get rid of the n minus 5, I multiply both sides times n minus 5, and then this one cancels out. It's supposed to be n minus 5. So then what you end up with on the left side is 8n minus 40. And then on the right side, you would end up with 3n. Okay? Because all I did was, multiply this there and this there. Same thing over here. If you're like, I'm going to multiply both sides times 2 so that cancels out. That gives you 6g plus 4 on the left side. Then I got to multiply both sides times 12 to get rid of this, which would give you 12g. We'll do this a little bit backwards because now I know that I'm going to leave the 4 there, subtract the 6g. I'm going to have 6g. It looks like I'm going to have 4 over 6. In other words, 2/3. Now going back over here, I think you can maybe see it. You would end up with 5g, that's actually an n, 5n equals 40, and an answer of g is 8, if I did everything correctly. And I'm just going to leave that there for you to look at for a minute. Make sure you understand how I got everything before I move on to number 13. Now, 13, what they really did on this is they looked at every single side and said, or every single part, and said, how can I get common denominators on everything? Looks like the number that they have in common is 15, and that they all would need a w. So really what they did is they ended up saying, I'm just going to I always forget to go back to the pen. No, don't do that. There, let's try that. So they really took the whole thing and said, I'm going to multiply the whole thing times 15w, because that way everything has the same denominator. So let's see what happens when I multiply everything times 15w. I know over here that the w would cancel out and the 3 would cancel out, and we'd be left with a 5 up there. In this one, the 15 would cancel out, and we'd be left with a w up there. And here, the w would cancel out, and the 5 would cancel out. We'd be left with a 3. Now, this really will work nicely because you'll end up with, 5 times 2, you'd end up with 10 equals 2w plus 36. Wow, that's interesting. And that certainly looks a lot better. So the thing for this one, again, before I move on to the next part, is, for that one, they had those 3 different parts. They just looked to see what would make a common denominator across everything. And then hopefully, it will make things a lot easier as we go along. We'll see on 15, 17, and 19, see if that helps. Now, if I move this stuff around, I should get negative... I should turn on my... Why didn't... Anyway, I should get negative 26 equals 2w, and you should get negative 13 equals w. Okay? Let's look at 15, 17, and 19. Okay, so for 15, it's the same kind of thing that they did. They went through this and said, let's make sure everything on both sides has the same denominator. So in number 15, which is the hardest one. I might actually do 17 and 19 first, because on 17 and 19, the only thing you're missing is that this side on the right side needs an a plus 3. So I should be able to just do, let's see, 2 times a plus 3, that'd be 2a plus 6. That's 2a plus 6, because I multiplied the top and the bottom times a plus 3. Now, if everything on both sides has the same denominator, then you know, because this right now wouldn't just be like that. It would be over a plus 3. And if everything on both sides has the same denominator, then you can get rid of the denominator, because you basically say, oh, I'm going to now multiply every side times a plus 3, and they will all cancel out. Or in other words, if you would just multiply the left side times a plus 3 and the right side times it, then you'd get that. So we should have this now, where we should have a plus a squared equals 2a plus 6. Now you got to get everything on the same side. Now, I would love to keep that a squared as positive. So I'm going to put a squared. I'm going to move the 2a to the left, which would give me negative a, because a minus 2a, and then again minus 6. Now, that's going to leave us with that. I'm pretty sure at this point that I'm going to get a minus 3 and a plus 2. And then if I set both those equal to 0, I should get answers of 3 and negative 2. Okay? Now, you do have to check to make sure that if you put either of those answers in, the 3 or the negative 2, if you put them into the original equation, you don't get any weird zeros on the bottom. And if it doesn't, everything's fine there. Okay, so I want you to understand the main part on that one is how I multiplied both sides by the a plus 3 to get rid of this stuff. All right, let me erase some of that. Okay, so now again, number 19 looks like it has that nice situation where I just multiply everything on both sides times n minus 1, because I really want to get the same denominator. So I would multiply top and bottom of everything times n minus 1. And what I would get if I multiplied everything on both sides times n minus 1 is all of this would cancel out. So it has the effect of, again, I'm just going to multiply this left side times the n minus 1 to cancel them out. And if I multiply the top of everything over here times n minus 1, if I multiply this times the n minus 1, that takes care of it. You don't even really need to write that down. But that really does shorten things up, because you get 3n plus 6n minus 9 equals 6n minus 6, multiplying this right here. So from this point, you end up with 9n minus 9 equals 6n minus 6. Okay, so let's move some stuff around. If I add the 6 to both sides, I'm going to get negative 3 over here. And on the right side, I guess I'm doing it negatively, 6n minus 9. And why am I doing that? I don't know. Maybe it's because somebody's dancing in the background right now. Negative 3n. It looks like I'm going to get n equals 1. Let me just double check my answer and see. So now that is the right answer. The negatives cancel out. But if you put it in there, you'll notice that if you put 1 in for n, you're going to get zeros on the bottom. And so that means that's an extraneous solution. I love that term, extraneous solution, which means then no solution on that one. There you go. We'll move on to the next one. All right. So 15. Ooh, this one's just ugly, because I look at each part and I see they have an x plus 1 and an x minus 1. Wow. X plus 1, x minus 1. I think if I remember right, I'm going to keep them separate for now. That means each part needs to get x plus 1 and x minus 1. Now I'm going to try to do this by just leaving it over here, because I know that this right here is going to need both parts, because I'm trying to get rid of everything over there. So this over here is going to need x plus 1. So the right side is going to need x plus 1 and x minus 1. This one, the first part on the left, that one only needs x minus 1. Because that would allow this to cancel out with the x plus 1. So that means the first part is going to be x minus 1, x minus 1. Okay? So that one's going to be like that. Now the second part, this part, to make that cancel out, that means the x minus 1 would go away, and I would still have the x plus 1. So I'm going to have the 2x and the x plus 1 there. Oh, that's lovely. Yeah. All right. Now I got to remember there's that minus sign there. So, I'll come back to that. Let's see. Make sure I'm doing everything right now that I drew that one part so badly. Yep, that's x plus 1, remember. Okay, now over here, I'm going to have this negative 1 and then times x plus 1 and x minus 1. This one's just the ugliest one of the whole bunch so far. I hope there's nothing worse when we get to the last couple. We'll see how it goes. All right, so right here, first part, x squared, and then minus x, that's minus 2x and plus 1. So that's all of this right here. So that's all of that right there. Now on the next part, I know I'm going to have, let's see, 2x squared, because that's that part times that, 2x squared, and then plus, and that's plus 1, so that's plus 2x. But those are both subtracted. Got to keep track of that. Minus 2x squared minus 2x. All right. Yikes. All right. We'll get back to that in a minute. Now let's change color again. Let's go over to the right side. I'm just doing this part first. X squared. Now, x and minus x, not going to be there. Minus 1. All right. So, because that's a difference of squares right there. That's hopefully what you're seeing there. All right. Now, but that has to be times negative 1. So that means negative x squared plus 1. Okay. Now, interesting. So let's see what all happens here. Let's start on one side at a time. I have an x squared and minus 2x squared. That's going to be negative x squared. All right, so I took care of that and that. Now the x's, that would be negative 2x, negative 2x. It's going to be negative 4x. And then I believe, okay, took care of the negative 2x, the negative 2x. All right, and then the only thing I have left is plus 1. Okay, other side, I have negative x squared plus 1. I have a sneaking suspicion I know where this is going. All right, now, this is when you should see, you got stuff on both sides that matches exactly. This and this match, and this and this match. So, I mean, if you move them to the other side, whatever, it just means this and this go away, and this go away. It looks like the only thing I have left at the end is negative 4x equals 0. In other words, x equals 0. Now, I do have to look back at the beginning. If I put 0 into anything for x on the bottom, it doesn't make an uncomfortable 0 situation. So I think at this point we're done. That was a nightmare. Whew. But let's see. We only have 2 left I want to look at, and then we should be all good. Okay, so let's look at 33 first. Now, don't panic yet, because, sure, it looks ugly. But the thing I notice is I remember from the other ones that when I have the x minus 1 and these two match, which is kind of nice. I'm looking at 35, and 35 is not quite as pretty, but it's not bad. I know that to get rid of those on the bottom, I'm just going to have to multiply everything on both sides times x minus 1, which is not bad, because then on the left side, I end up with this. X squared minus x minus 3 plus x cubed plus 2x squared. All right, not the prettiest thing ever, but we can see what happens. And then over here on the right side, we now have 3x minus 3. Okay, so mostly I want to make sure that you understand that we just looked at the bottom here and said we need to get everything. We need to get rid of that. And so I just multiplied everything on both sides times x minus 1. That, multiplying this and that times x minus 1. That way it cancels out and we're left with this. Okay, great. Let's start combining some stuff and see what happens. So let me change my color. You can see what direction I'm going here. I haven't used brown yet. That's a lovely color. X squared, 2x squared. That's going to give me 3x squared. Okay. Oh, I forgot about the lovely x cubed. And so took care of that. Let's see. Now, I've got some x's. I guess it'd be nice if I brought all the x's to the same side. I've got this negative x here, but I think I'm going to try to get all the x's over to the left. So that'd be minus 3x. So that would be negative 4x. And then, okay, so took care of that. Now, the other thing I seem to have is I have a negative 3. But if I add that to that side and that side, it cancels out. So I believe at this point, I have this. Now, I'm going to rearrange this and move stuff. Okay, so all I did was I moved this and this so that, things are in the right order. Somebody wants to be heard today, apparently. We have people outside working outside our house, and, that is just terrible when that happens. Now, at this point, you might be going, what do I do? Well, the first thing I look at is step 1 in all of our factoring is what do they have in common? And they all have x in common. So when you bring an x out, you end up with x squared plus 3x minus 4. And now that makes it easier because you can look at this and go, hey, how do I get a negative 4 and a positive 3? I think that must be x plus 4 and x minus 1. And we still have the x. Now, that's perfect. And now all you got to do is set each part equal to 0, which gives you x equals 0 and negative 4 and positive 1. Now, you do have to go back to that original equation. And I noticed that in the original equation, there is one of these that will not work because this one will not work in that original equation. You put that in the bottom and you're going to get a 0. So there you go. That's number 33. One more, and then we're done. All right. So for the last one here, 35, that is, first thing I notice is that this x squared minus 5x, that is going to be something where I need the pen. That is going to be x times x minus 5. You want to start there first because then that helps you see that to get the matching parts on everything, you don't need to do anything over here on this side because this side already has it all. Has the x minus 5. This one here, why did they have to put fractions? This one, the x, this one needs the x minus 5, which I'm not excited to do. And this one here just needs the x. So that'll get rid of everything on the bottom, and everything will have what it needs. Okay, I'm hoping this is going to be nice to us because I'm not encouraged right now. I think I see something that'll be positive, though. All right, let's start with the easy side, the right side. This one stays as x plus 21, and that's it. The rest is just like it is. So they don't even give you any fractions and anything else. That's kind of nice. All right, so then this one, I know we're going to get x squared. Now, I'm going to do this already. It's going to be minus x squared because there is a subtraction in there. And then it's going to be plus 10.5x. Okay? So that part's done. Now, the very far left side, again, you're going to have an x squared And at the end, we're going to have a plus, let's see, 5 times 6 over 5. The 5 should cancel out. That should be a plus 6. If you see how I did that, I'm just doing the FOIL method. And then finally, we're going to have, let's see, negative 5 times x and negative 6/5 times x. Negative 5, so that'd be negative 5x and negative 6/5 x. So that would be 1/5. So negative 6. So I think negative 6 and 1/5 x. Why? Why do they do this? That's just disgusting. So negative 6.2. Let's just do negative 6.2x. Okay, I hope you got how I did that. Again, if I just change my color a little bit, I get negative 5 times x. That's a negative 5x. And the other one is negative 6/5 times x, negative 6/5 x. That's 1.2. Negative 6. That's just terrible. That's just sick and wrong. Negative 6.2x. All right. Now, the nice part is changing to something like blue. This and this cancel out. Hey, and you should always be happy when your x squareds disappear because it makes life easier. All right. So I'm looking at my x's now, looking at all my x's, and I'm going to try to bring them all over to the left side because the biggest x is right here, the 10.5. So the 10.5 minus the 6.2 would give us 4.3x. But then you're going to subtract another x, that one right here, 3.3x. All right. So I just took care of that and that and that. And I might as well then move the 21, or leave the 21 there, move the 6 over there. I believe that's going to give me 15. 21 minus 6, minus 6, minus 6. Okay? This one's not that bad other than that ugly 6.2 junk. So now 15 divided by 3.3, as much as, I'm just thinking carefully in my head. Definitely I'm not using a calculator right now. I'm not going to my phone and I'm not typing in 15 and dividing it by 3.3. My brain is just telling me a terrible answer of 4.54. The answer in the book had the people in the book must love fractions. And yeah, that's the answer they got, 4.54. So, wow. There's the whole thing. And there are others that are similar to the ones I showed you. You'll just have to take a look and see what things are questions that you have. So there you go.